Let's construct congruent angles and at the same time. The steps are at the top of the paper. I'll just be saying those as I walk you through it. Feel free to freeze and write that down if you'd like to. So the first step is going to be copied a segment. We're going to take a straight edge and we're just going to make an array that we can build on. Because I'm going to end up adding the two angles on the page together, I'm going to actually work towards the right hand side of my page to leave plenty of room to the left to add the angles. So I'm going to do something like that. Used a straight edge, made array. So I'm going to put it here at the end, put an arrow there. Our original angle is called A. So I'll call this one A prime since I'm going to copy it. I'm going to go get a different color and swing an arc. Here's my bullseye. Putting it on A. Swing this arc. I'm actually going to swing the same arc here on the angle I'll add later. It needs to be the same. But I need it here most of all on my new angle I'm creating. The exact same arc. Here it has to be, I love the word ginormous. I know it's not a real word, but it really has to be very big because it's going to have to be both angles added together. So I'm staying on my bullseye point. I'm coming way back here. The first hole. Okay. So it's like this. I'm straight back, hoping it doesn't scoot. This is not easy to do. Let me try it. I can get a really big one. Moving the paper is easier for me. Okay, the point is this large arc I'm going to intersect this line. I'm trying not to do a full circle. I'm trying to come all the way around. You see I got stuck. Trying to hold everything firm. There. The key point is that from the vertex of the two original angles has to be the same distance as my A prime out to here. So after I've done that, I'm going to go to my original A. I'm going to capture the distance of opening represented on the arc. There's my bullseye over one point of intersection, bullseye over the second. Slide my compass over here to the intersection on the ray I copied to start. This point here, when I connect it back to A prime, will give me my first angle. The amount of degrees of opening here on the original angle are congruent to the amount of degrees of opening here. I could say angle A. Notice the angle symbol. It is not a less than sign. It's not the letter L. But this angle is congruent to angle prime. Okay. So now let's go look at the second angle we want to add on. The distance between where it intersected drew over here. Using the bullseye, with intersections, I'm going to slide it over here. First angle and display, make a new point. I think I'll switch colors. Now, if I go back to my vertex and connect it to the point of intersection, I've copied that larger angle there. I'll put an F so we know. So now we know that angle F is congruent F prime. If we want to show the angle addition in this problem, we could say angle F is congruent to angle, I can call this point X, this point Y, this point of E, angle I, Z. Also could have said angle A prime plus angle F congruent to angle X, Y, Z, since they're all congruent measurements. If we ever want to talk about the measure of these angles, if we happen to know how many degrees were there, then you say the little m italicized angle X, Y, Z, if we wanted to do the total of this opening here, and then we would put equal degrees. I just don't have a measurement on it, nor a tool nearby to measure it. Protractor. Let's go ahead and look at measuring. you put your vertex right on the point where this horizontal meets this vertical, and you line up the horizontal on your angle, and you see where the ray shoots away from the vertex. And since I know I'm looking at something over 90 degrees, I'm looking at my lower scale here. That's almost 150 degrees. It's more than 140. It's more than 145. Looks like it's about 147 degrees. It's like about 147 degrees.